Yesterday you found inverses by simply switching the x and the y. Today we're going to write the inverse of a function, so we're going to start out with a function. The first thing that you're going to have to do is we're going to change this f of x to y. The next thing that we're going to do is like what we did in the table. We're going to look at the x and the y, and we're going to switch the x and y only. So now we're going to rewrite this as x equals 8y minus 5. Okay, so we changed the f of x to y, we switched the x and y, and now we're going to solve for y. So what that means is I want this y by itself. So I'm going to add 5 to both sides. That will give me x plus 5 equals 8y. And then I'll divide both sides by 8. So now we have, I'm just going to write it up here, x plus 5 over 8 equals y. Now the last step is to write f inverse of x, because that's the notation that shows that what we have here is an inverse. It's not the original function. So we're going to write it as f inverse of x equals x plus 5 over 8. Now you could also split that up and write f inverse of x equals x over 8 plus 5 over 8. Okay, the next one we're going to do, yesterday I told you that inverse functions reflect over the line y equals x. So that means when x is 1, y is also 1. All right, now I'm going to give you a line to write in. F of x equals 2x plus 1. Okay, now this line has a slope of 2 and a y-intercept of 1. So you can graph that, or we can pick some points. If I give you the points 0, 1, 2, and 3, if we substitute 0 in here, we'll get 1 for y. Substitute 1, we'll get 3. Substitute 2, 2 times 2 is 4, so that's 5. Substitute 3, 2 times 3 is 6 plus 1, so that's 7. This is the function. And then if I switch the x and y's, I'll have the inverse. So the inverse over here, this is from yesterday. I'd put all the x's. So this would be, let's see, 1, 2, 3, 4. Put all the x's where the y's are. Put all the y's where the x's were. Okay, so now we are actually going to find the inverse, and then we're going to write and graph its inverse. Okay, so let's just graph this first. It's f of x equals 2x plus 2. So this is going to cross the y-axis at 2, and then it's going to go up 2 over 3. You can also go down 2 and over 3. Down 2 and over 3. The more points you have, the better your line's going to be. So we're going to go through these points right here. And now we're going to graph the inverse. So without using the table, we're going to follow our steps, which says we're going to change the f of x to y, and then we're going to switch the x and y. So this is going to be x equals 2 over 3y plus 2. All right, so now we're going to solve for y. So that means we're going to subtract 2 from both sides. So now we have x minus 2 equals 2 over 3y. Okay, now you can do this all in one step. We could multiply by the reciprocal here. Or if you want to do it in 2 steps, we could multiply both sides by 3. And that's going to give you, if I distribute this, 3x minus 6 equals 2y. And then I could just divide everything by 2. So that's going to be 3 over 2 x minus 3 equals y. Okay, so remember, we want to write this as f inverse of x. 3 over 2x minus 3. So we're going to go down here, 1, 2, 3, and then we'll go up 3 and over 2. Up 3, over 2. Up 3, over 2. Then we can go the same thing this way. Down 3, over 2. Oops. And we can draw our second line. Now remember, you always need to include the line y equals x. So again, that is x and y are the same value. So 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and so on. Down this way also. So this would be a dashed line, y equals x. So now if we would fold our graph right along this dashed line, this line would be right on top of that line. And that's how you know if you have graphed your inverse correctly. Okay, you have a you try it to do.